Good morning. Let's look at section 9.4, arithmetic sequences. Oh, arithmetic series, sorry. Can already hear you whining. I gotta write it again. I'm kidding, all right? Relax. I'm sorry. I made a mistake. Give me a break. Gosh. All right, first off, we need to review. Arithmetic means we're adding each time, and the series means that we're going to add the numbers up in the list. So let's see what we're talking about here. Let's see here. The first thing I need to do is review. And this is from section 9.2. A sub n, if it's arithmetic, which this is equal to a sub 1 plus n minus 1 times d. Okay, where n is the nth term, a sub n is the nth term, a sub 1 is the first term, d is the common difference. Okay, let's see what's happening here. So we will consider this arithmetic sequence 2, 5, 8, 11, 14, 17, ... So we have this arithmetic sequence. The common difference is 3. We're going up by 3 each time. And the first term is 2. All right, let's see what we got here. The notation that we used before, we'd say something like, well, what's a sub 4? This is the fourth term, so we count 1, 2, 3, 4, and that would be 11. Okay, so a sub 4 is 11. Okay, so this means the fourth term. Well, we're going to have something different here. S sub 4. This means sum of the first 4. This means sum of the first 4. And I'm very excited about it. I'll put an exclamation point. You should actually be careful. That means something else. So, sum of the first 4. Well, what are the first 4 terms? 2, 5, 8, 11. So this says S sub 4. Take the first 4 terms and sum them up. So 2 plus 5 plus 8 plus 11. Let me see. That is 26. Okay, so when I'm talking about a series, I'm adding up the terms. So this is a sequence, and this is a series. That's the difference between section 9.2 and section 9.4. When it says sequence, just make a list of numbers. When it says series, you add those numbers up, giving you a total. Now this is math class. We also have a formula for this. We have a formula for the series. Okay, it's n times the average of the beginning and the end. So over 2, a sub 1 plus a sub n. So the sum is also the number of terms n times the first term plus the last term over 2. Let's see if we can apply this to this sequence right here. I'm sorry, this series right here, even though I already know what the answer will be. So 2, 5, 8, and 11. I want to add all those up. Okay, well, n is 4. A sub n, the first term is 2. A sub n, the last term is 11. Okay, let's do our math here. And I'm actually, 2 plus 11 is 13, and that doesn't divide evenly. So I'm going to divide this into 2 instead. 4 divided by 2 is 2. Times 13 gives me 26. And it's no coincidence that I got the same answer here and here. Okay, sum of the first 4 terms is 26. Now this formula is kind of silly when you just have 4 terms, but if you had 1,000 terms, it would be much easier because you only need to know the first and the last terms. Beautiful. Okay, the last thing I want to talk about is something called summation notation. And it's a way to write out sums in a more concise way. Okay, so here is the sentence. I'm going to say, hey, y'all, I want to add up whatever 2n is for values of n between 1 and 43. Okay, summation notation, the way I could shorten this up is I would say I'm going to add up. This is the sigma we're going to write here. It's the Greek letter sigma. Okay, we're going to add up 2n from n is 1 to 43. So it's kind of a crazy loop-de-loop we do to translate this. Add up 2n with n starting at 1 and going to 43. Okay, and if I wanted to do this, I'd make a little chart. From 1, 2, all the way down to 43. Let me see, so 2n, that would be 2, 4, 2 times 43 is 86. So I would have to add up all these numbers. Okay, that's what this and this both mean. If you're going to add up 2n for values of n between 1 and 43, you're going to add up all these numbers. You're going to add up 2n for values from n equals 1 to 43. That's it for your notes. Thoughts for the left-hand side.